get together and do this in person. So they do a lot of it remotely as they go through there.
Yeah.
Hey, everybody. Hey, in the chat, we're going to get started here in about 4 minutes. We will dive in with Mark Peterson. So, yeah, are you into those? Do you like those kind of things, Mark? Those
Oh yeah.
competition make thing shows?
Yeah, I mean, yeah, that's like, I don't know. They're like super entertaining to watch, like real easy to watch kind of stuff. So,
Yeah.
but yeah, I like binge like these like bake off shows and stuff. Like, I don't know, you're eating lunch or whatever and you're like, "Oh, I'm just going to watch this for like 10 seconds." And then you end up wasting like 3 hours like watching this thing. You're like, "Why am I so into baking? I don't even know how to bake." Like,
Yeah.
you just constantly like the next one just plays, the next one just plays.
I have a guilty pleasure. I like that. So on the history, they have that show Forged in Fire, where these guys have to come and like make a
Yes.
knife out of like ball bearings and broken cars.
Yeah. 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 They like MacGyver some stuff together.
Yeah, I'm get this chat up here. Hey, Mike Puckett, glad to see you in the chat. Aditya Patil, hello to you. Eric Beatty, see we got you in the chat. Yeah, we're gonna be getting started here in just a couple of minutes. So check that out if you haven't seen it. Assembly Required, a pretty cool show. It's all about makers given a challenge. I haven't seen any CAD on the show yet, so I don't know if they're like designing, but they're doing a lot of really cool engineering on that show, which I really like.
Yeah, that's it's a ton of fun. I mean, if you have access to like a maker space or like what I'm going to show today, like I got this 3D printer that I stole from Mike Puckett. And it's yeah, it's awesome, man. You can do all kinds of cool stuff. You like the guitar right there, like I printed off like one of these just as an example, like this little like holder for it, which is pretty
Oh,
cool.
cool.
So and it's like, I don't know, it's just fun. You can kind of like just make whatever, and especially like, with, I don't know, X shape and tools like that, you can, I don't know, your imagination kind of run wild, and then you just sort of start printing stuff. I can't imagine like what it must be, if, like, you have kids and like you can just, I mean, kids love that stuff.
You make a cardboard box.
Yeah.
Because that's what kids like, right?
Yeah. They start playing with the box that the 3D printer came in. Like, this is awesome, Dad. Thanks.
Hey, Brian Wade, Ray Falks, welcome to Live Design. We're going to get started in just about a minute here. It looks like Mike Puckett actually had 3 of those 3D printers. It sounds like this one had a few challenges, though. You had to do a little work on it, right?
Yeah. Yeah. So in my previous life, I did a lot of repairs on commercial 3D printers, like the, industrial ones, like big size guys. So all kinds of different technologies. So yeah, Mike said there was something wrong with this one. And, I was like, okay, let me see if I can, maybe turn it into a weekend project and, get it fixed up. So I was able to get it fixed mostly. I'm still having trouble with like the support material, but I don't know, these things can be kind of finicky sometimes, and they just require like a magic touch sometimes. You know what I mean? Like, it's not anything that you're doing. It's just, they're just being ornery. So.
All right. Well, that's a perfect segue. I think we're at the top of the hour. I think we're going to go ahead and get started. Welcome everybody to SolidWorks Live Design. I'm Jeremy Rigneris. I'm going to kind of moderate the chat as we go through here today. And I'm joined by Mark Peterson, who's going to be your presenter covering. Why don't you tell us, Mark, what you're going to be covering here today?
Yeah. So I guess, I was just kind of noodling around with some ideas for live design, and, we've all kind of been relegated to sort of home offices. Many of us have over the past year or so. And, like we were talking about just previously, I got recent access to this 3D printer. And so I was like, oh, let me see like what around the office I can kind of like, improve with my 3D printer. And So I came up with a couple ideas, and I thought, oh man, this would be kind of fun to show like the design process from, having a challenge or like something that I wanted to improve. And then, how would I design that in SolidWorks? And then, how would I send that to my 3D printer? And, how does it solve a problem? So, just kind of like a little bit of a 3D printer workflow. And, SolidWorks is a great tool for that, because it has a lot of really great tools baked in. We're going to talk about, the 3D print tool inside SolidWorks. We're talking about the thread tool inside SolidWorks, which doesn't get highlighted so much. So I think that's really cool. So yeah, a lot of fun stuff.
Sweet. I can't wait to see this. You've already mentioned two capabilities. I'll be honest, I use SolidWorks for decades. That's scary to say. And I don't use the thread tool very much, and I've not used print to 3D, myself. So I can't wait to see. Hopefully the audience is excited as well. If you have any questions for Mark, throw them in the chat. I'll be watching the chat. Mark, I may interrupt you as the audience has some questions for you as we get going, but I'm going to kick back and I'm going to kind of just watch what you do here. I can't wait to see this workflow.
Cool. Awesome. All right. Yeah. So, I have like a little PowerPoint here that we'll just get started with. And, so, I took the inspiration of, the old school show Home Improvement. I love that show. I thought it was just so funny. So I went into SolidWorks and traced out the Home Improvement and snuck Office in there. So I thought it was pretty cool. So I could have it in 3D, which I don't know, it was kind of fun. But,
Mark, can I ask you a question? When you finished extruding it, did you do the voice that he makes?
More power. So yeah, it was a good show, but anyways, that was just for fun. So let me talk about the problem that I was having. So when we got into kind of this pandemic thing, the webcam market was going crazy. It was going gangbusters. Logitech was making money hand over fist because everybody needed a webcam all of a sudden. And I didn't get in on it as soon as everybody else did. So I had this really kind of not cheap webcam, but it was like made for being portable, and it wasn't like a very good quality one. And so, for my job specifically, right, we kind of have to get in front of the camera sometimes, and we want it to look, good. And I felt like the quality of my camera wasn't doing it. However, I do a little bit of like photography as a hobby. There's some of my, stuff in the background there, but so I had this camera, which is like a kind of semi-professional camera. It's not a great camera. It's a good one. And, I use it for photography. So I thought, why don't I just plug this into my computer and see if I can use it to, for video conferencing and that sort of thing. And it sort of worked, and it was nice. The only problem is, when you're doing that with one of these cameras, it's kind of like sitting above your monitor, and you're always looking like this. You're like looking at your screen, and so you're not having any kind of connection with the person that you're talking to. Like, this is very awkward because I'm not actually looking at you. So it's much better when I'm looking up and I can, sort of make more of a connection with the person, either as the audience, or maybe I'm, in a one-on-one conference call with somebody. This is a lot better this way. So I also had a portable monitor. So this was like something that, you could put into your bag, and like, when you're because we used to travel a lot, but you would pull it out at the hotel, and you could have like multiple monitors. So you could actually feel like pretty productive when you're on the road. And this is like a little, I don't know, 7, 8, 9-inch kind of display that runs off a USB-C. It's, super convenient, and it really just elevates your travel experience, especially when you really feel like you need to get a lot done. So of course I wasn't using this anymore, so it was just collecting dust in a drawer. So I thought, can I just like put this monitor on top of this camera, and then, I would be able to, have a better, connection with my audience when I'm, doing that sort of thing. So I was like, okay, well, what's going to go in this space? So on top of the camera is like a little rectangular, input. It's called a hot shoe. And I have this little guy here. And so this is like let's see if that works. It's got kind of a rectangular profile on the bottom, and then it has a quarter.
Oh. Mark, I'm having a bit of a connection issue here. Looks like you froze up a little bit. I don't know if you freaked your camera out by trying to get it to autofocus.
Oh, sorry. Hold on. Let's see.
No,
Let's see if that.
You're good now. It was literally like when your camera tried to autofocus, it like kind of.
Oh, really? Okay. All right. Sorry about the technical glitch there. So that's the thing that we're going to do. We're going to try to, create something that's going to work with that quarter 20 thread. So let's get into SolidWorks and we'll get started finally after that huge intro. Cool. So
hey,
along the way.
So
yeah.
Mark, quick question from chat. Joe Zenkis wants to know if this part has been sponsored by Binford Tools.
Yeah, definitely. That's I should have put some plugs in there. That's funny.
Yeah.
Cool. So along the way, I'm just going to pepper in some like tips and tricks. A lot of them we've shown on this live design before, but it's always good to reiterate some. So I'm just going to start with a millimeter template, a part millimeter template, and the first thing I want to do is I want to get started by designing the monitor itself, because that'll give me kind of an idea of what I need to wrap around it in order to hold it. I could just measure it, with I don't know, like calipers or whatever. But if you wanted to do this for yourself, you may want to use an iPad or something that has like some curvature or something like that may be a little bit more difficult than sort of the rectangular monitor I'm dealing with. So something I always like to do with projects like this is I like to use Sketch Picture, which allows me to sort of bring in a picture of something. So for example, here, I can just open this up and I have this monitor. Now, in picture format, it comes in like really big. So I'm going to use the F key on my keyboard so I can zoom to fit. And so I can actually see this thing. And so we can see the monitor. And of course, for convenience, I have a ruler or a scale that I put on here. And I want to size this to the appropriate size. So what I'm going to do is use this and the scale tool. I'm just going to drag these handles, and notice it does kind of snap to horizontal, which is nice. So we'll put this here, and then it's going to ask me for a dimension. So I'm sure many people have probably seen this tool before, but this is just, to me, like such a great tool. You just kind of snap to something, and you already know exactly what the dimension is. So we'll say that's 220 millimeters. Of course, it flies off into outer space, so I have to hit F for zoom to fit again, which is wild, but that's okay. We're going to kind of move this thing over
Mark,
here.
that's a really cool tip. The fact that you put your scale, your ruler on top of the device that you are going to be bringing the sketch picture in. I absolutely love that. That's a great tip for people who use Sketch Picture.
Yeah, absolutely. It just gives you something like that is the exact right dimensions. So that's pretty much most what we need to do here. I do kind of want to have this somewhat either like centered or something. So maybe I'll do like kind of centering, but how do I know exactly where the center is? Well, I can do some, sort of sketching in here. So let's just create a quick rectangle, something like that. And, this rectangle is fine, but, it's not going to help me like center anything. So, let's try that again. I'm using my S key here to bring up this shortcut. And I do have this drop down that lets me choose different types of rectangles. So here, instead of doing just the corner rectangle, I'm going to use the center rectangle. And I'll just do a center rectangle on this origin. And the idea here with this rectangle isn't to have the exact right dimensions. It's just something that gives me a gauge that I can use to kind of center my picture on. So I have kind of a rectangle here that's about the right shape. It's not super important. I want to get back into that sketch picture. So I'm just going to double click on the sketch, and we're just going to kind of drag it around until it's about in the center, which I think is right about, let's say, there. Again, it doesn't have to be perfect. We just want to get things about right. Okay, so I've got that. I don't need this rectangle here anymore, so I'm good. Okay, I'm going to exit my sketch. Now, a lot of people might go ahead and just start sketching around this in the sketch where the sketch picture is located. But a real big tip here when using sketch picture is just to only have the sketch picture in that sketch. And the reason why is because you can come in here and you can hide this later very easily just by selecting the sketch and choosing to hide or show. And we're going to be using that a lot, especially when we do sketch picture. So that's the front of it. We do want like the profile of the side or the top. So let's choose our top plane. We'll sketch here. And again, we're going to use the sketch picture tool. And if you're wondering, how did I get sketch picture on this toolbar? We can customize any toolbar inside SolidWorks. It's highly customizable. So of course we'll go here. And if I want to search for something like sketch picture, I can just search for it and then drag and drop these on here. So, and if you don't want it on there, you can just pull it off and get rid of it. You see my little X next to my cursor. And so because of that, customizability, I can put extruded cut in there.
Hold on a second, Mark. We have we have an interesting comment from Mike Puckett in chat, and I think this is a great question to ask the chat. Mike says S keys greater than mouse gestures. So I have a question for the chat. If you use the S key, press 1. If you use mouse gestures, press 2. If you use them in combination, press 3. Let us know what you're using. S key, mouse gestures, or both. 1, 2, or 3. That's a great comment, Mike, because I'm not going to go into the debate about which one's better, but I'm curious what our users use more. 0 if you don't use any of them. Sorry, Mark, keep on going.
No, I'm interested in the results as well. I use the S key a lot. I think I don't know, just for me, I think the benefit to me of the S key is if there's not a command that's in my shortcut toolbar, I can just start typing and the command will come up in command search, which is nice. So okay, so let's get this other sketch picture in here. And you know what? Sorry, one other thing I want to do here. Let me just close this out. Okay, let's go back to this original sketch. I do want to have a midpoint line in here, and you'll see where this line is going to come into play here in just a second. So I just want this midpoint line in here, and that's also going to be 220. Okay. So I'm going to use this line to snap my new sketch picture too. So let's go to our top plane, and we're going to repeat our sketch picture. So I have this one here. We'll open that up. And again, it comes in pretty large. So F for zoom to fit. And I have a pair of calipers here. So I'm just going to use the ruler on the calipers, which is going to be pretty convenient. So I'll just drag and drop this onto here. That's going to be 10 millimeters. And we can kind of move this over here. Now the orientation, because of the way I took the picture, the front of the device is up here near the top. But that's okay, because in the sketch picture properties, we have options to rotate and turn things around. So for example, if I want to rotate this around, I just type 180 degrees and I can move it around. So it's very versatile, being able to use this tool. I'm just going to kind of drop that again. It's pretty close to in place somewhere, something like this. There we go. Perfect. And again, I'm going to exit that sketch because we don't need to have any other sort of sketch elements in our sketch picture. So there we go. So we have those two in there and we're ready to start designing. Let's go to our front plane and we'll sketch here. And we can do our center rectangle tool again. We'll pull out a center rectangle and we'll get it just like so. And you'll notice that the picture doesn't line up with the sketch. And the problem isn't the sketch. The sketch is truly accurate. It's the picture that's the problem. Most cameras have some sort of bend or angle to them, depending on how you take the picture. So don't let that get in the way of a good time here. So all right, let's add some dimensions. We know that this one is 220 for sure. We don't know the vertical one, but it's very close. Let's say 150 is about right, and we feel pretty good about that. And so let's extrude this. So we go to features, we'll extrude that. And of course, we have our sketch picture here, and we can even use this to determine how much we should extrude. So should it be 11 millimeters? It's about right. Maybe 12 makes more sense. Maybe 11 and a half.
Mark, I love your use again of a measuring device on your sketch picture. This is like a really cool tip. I love, I know you've been working for a little bit. I'm kind of going back to it. I like how you actually put the measurement on the calipers themselves. What a genius way to get your scale down.
Yeah, the whole point is try to get as accurate as possible with these. In a lot of cases when you're doing sketch picture stuff, it's usually off of a drawing, and they're sort of giving you dimensions. So it's very infrequently that you would necessarily have to use it in this way, but sometimes you do, and this is a great way to try to get as accurate as possible. So, okay, cool. So, this device has some, chamfered corners. So I'm going to select this edge and choose chamfer. I love doing chamfer this way just because it's very easy. I already know what edge I'm going to select. So I just put the chamfer on there. I'm going to select these different edges. I love in SolidWorks how you can just pick through geometry. It highlights that edge for me, so I don't have to rotate things around or anything crazy like that. And then we'll confirm. Now we'll see from my sketch picture that my chamfer isn't quite right, but I'm going to use Instant 3D. And just so everybody knows where that is, on your features toolbar, you've got this Instant 3D here, which means I can grab this blue orb and I can just adjust it. I can drag it against this ruler to get it, like these exact numbers. Or you can kind of freehand it. If you're left of the ruler, you can kind of freehand it. So notice I can go, as fine or as granular as I want to on this. I'm going to make it like 7.5, something like that. Just put it in there. I'd also like to fillet these edges here. So let's go ahead and get those fillets going. Now 10 is going to be a little much. Let's maybe make it 3 or something. And notice when I click on another filleted edge, I do get this pop-up here. So I can kind of zoom out. So when I click this edge, we see that I get this pop-up. So this is my little filter selection helper. And notice that it's going to collect all 6 edges that I actually would have selected myself manually, but it's going to do that all in one go. And that's just a super handy, tool for us designers. It saves us a lot of time. I also used my right-click mechanic there to confirm that, so I didn't have to go all the way to the confirmation corner up here in the top right to confirm it. Just another time-saving tip that I like to use all the time.
So, Mark, we've got our results in, and it's 3. It's everybody uses a lot of people use a combination. Now, Mike Puckett said maybe he should have bribed people with some CSWP certificates to vote on his side.
Yeah.
But that's great. I love seeing that a lot of people are using, all the tools that are going to make their lives faster as much as possible. So that's really good. And then Brian Zaya said 3, but 1 is awesome, especially in 2022. Did you watch 3D Experience World virtually, Mark?
I watched it all week for like hours and hours and hours. I don't know if I even took a break to eat. I think.
Do you know what he's talking about? Do you?
Yeah.
Technology. If you're watching at home and you haven't watched the technology previews or the don't miss this demo sections, go back to 3D Experience World and watch those technology previews. There's a really cool enhancement coming to the S key in 2022.
That's right. Yeah, absolutely. Yes. Yeah, definitely go watch that for sure. Okay, cool. So let's continue on now. We'll notice here, I'm going to hover over my solid object and hit tab. It hides it for me even in part mode. That used to only work in assembly mode, and a couple of years ago, the developers changed it so we could do this in part mode. But you'll notice there's sort of this feature here that goes around the face of the part. It's kind of like this indent. So we want to replicate that. I'm going to use Shift Tab to bring my part back, and let's go ahead and start sketching on the top plane. Now this is actually here, so let's hide it again using Tab, and I'm just going to use my line tool to kind of create some geometry here. Doesn't have to be perfect, but I just want to create like a little bit of a cutout. So let's do something like this. There we go. I guess a little extra piece here. I'm just going to trim that out using my trim tool. And then I want to just get in here and there we go. It doesn't have to be perfect. I'm just trying to get something that's relatively close. And actually, I do have a little bit of something here. So let's do that. All right. Sorry, I'm making a mess of my sketch here. There we go. Normally, I'm way smoother than this. Sorry. All right. I'm going to just merge these two together. There we go. So now I've got like some sort of thing here. We really want to make sure that we always, fully define all of our sketches. And the reason for that is because, fully defined sketches are a lot easier for our CPU to process. If we have a bunch of underdefined sketches, there can be some complications for our processor, and it could make our parts slow and perform less well. However, I don't really feel like fully defining this because I don't know, it's like it would be a lot of work. So this is a tip that I use sometimes when I'm just trying to get something done. I don't recommend doing this in production all the time, but if you're just kind of, playing around, it can be pretty useful. So on your sketch toolbar under this display delete relations that you never look at, there's a drop down, and there's this tool here called fully defined sketch. And it's just sort of like a way that I can just define the sketch by hitting calculate, and everything is fully defined and we're good to go. Again, I wouldn't always use this in production, but it is kind of nice to have it here. So
a good example where you might use something like that, Mark, is you download a part from a supplier catalog and they didn't fully define, but yet the geometries, what it has to be, and you just want to lock everything down. I agree with you. You should never have minus signs in front of your sketches in the feature manager tree.
Yeah, yeah. So I'm using it here, and we're just going to do a quick swept cut. So I'll just go to my features tab. I'm going to choose that as my sketch profile. And for my path, I'm just going to select this edge. It's only going up to like that corner. So let me expand some of these options here. Clicked on the wrong thing. And there's this tool here called tangent propagation. So what that means is that any kind of tangency, it will just continue along that path. And then we can make that little swept cut just like that. So pretty nice to have that in there. So this is starting to look a lot more like my actual monitor. However, it is missing a screen, so we can create something like that. Now, my solid is kind of in the way, but we do see sort of what that screen is supposed to look like. So why don't we just sketch on this front plane here, and I'm just going to guess and do an offset entities, and let's just reverse that direction and hit check, and let's confirm that. All right, was I close? Yeah, that's pretty good.
Ooh, and we're very close.
Yeah, we're not, trying to build a rocket here. So, I just want something that's somewhat similar to the design. So let's go ahead and do a quick extruded cut. We'll select that, and it needs to be maybe a millimeter deep or something. Okay, cool. Now that looks like a portable monitor. That looks pretty good. So this is something that we can now use to create our little stand for our monitor. So remember, I have all these sketch pictures in here. I can just control select them and hide them if I don't want them in my view. And now my view is nice and cleaned up. So that's, again, another reason why we only put one sketch picture in the sketch, nothing else. Cool. Okay, so now for the part that's really fun, which is to create sort of our cradle. So what I'm going to do is go to my right plane, and I know that I want to do an extrude. So something that I've done is I've actually customized this menu as well to include an extrude or cut. This is a nice quick shortcut because most of the time we create a sketch and then we go up to our command manager and then we find the tool. Well, if you're always using extrudes and always using cuts, then you can just start with an extrude. So there we go. I'm going to do that again. And that's going to give me a chance here to create my corner rectangle. And good. So this is kind of what I want the corner rectangle to be, but I want it to be, maybe like 2 millimeters thick. So let's grab our dimension tool, and I'm just going to dimension off this geometry. So we'll say that's 2 millimeters from that edge. We'll do 2 millimeters from the front. Okay. On the bottom, however, I need it to have a little bit more because of that quarter 20 thread. I want it to have some space to thread into. So let's make that 5 millimeters. And let's give it an overall dimension. Let's just say 50 for now. And of course, we can always change this.
So now, Mark, I notice you're starting to design the cradle within the same part that you modeled the monitor in. You're not using an assembly. How are you going to mitigate like these parts just merging into one giant solid?
Yeah, that's actually a great question. So as soon as I exit this sketch, we're going to see that extrude property dialog pop up. So I'll use my D key to bring the confirmation corner to my cursor. Just another time-saving tip, the D key on your keyboard. D is in David. And now we have our property manager here on the left-hand side. By default, SolidWorks is going to ask you if you want to merge the result of these two solids. If we did that, it would just make them one chunk, one single density. And we don't want that in this case, just like you were pointing out, Jeremy. We actually want them to be two solid bodies. So if I uncheck this box, we'll see that it's going to have the two solid bodies in here. And then we can use some Boolean methods to subtract, for example. So, okay, so let's create that solid body. I don't want to do blind. I could just say, oh, I want it to be blind up to some amount. But remember, I do want my wall thickness to be, the same all around. I do want it to be consistent. So really what I'm looking for is for this face to be extruded just 2 millimeters beyond this one. And this is where we use our drop down for our end condition and build in some design intent into our design. So I have a lot of different choices here, but the one that's most appropriate for this use case is offset from surface. I select offset from surface. I select the surface I'd like to offset from. And then I say I want it to be a 2 millimeter offset. The offset is going towards the inside of the part. So all I have to do is reverse that offset. And now it's sticking out beyond the part. No matter how big the part grows or shrinks, it'll always maintain that 2 millimeter distance. That's what we mean by design intent. How do we expect it to change in the future? And how do we want our body to change? I want to do the same similarly to the other side. So for direction 2, offset from surface, we'll select our surface. We'll choose a 2 millimeter offset, and we'll reverse that to the outside. Okay, we confirm that. And I know that there are two bodies in my part, or in my environment here. There's a couple of ways I know that. One, we have a solid bodies folder here in the feature tree, and it does show both of my solid bodies. And in fact, I could even go in here and rename these. I could call this monitor, and I could call this cradle, for example. And we can name those, and that's that's a nice feature for us to be able to do that. Another way that I know that I have two solid bodies, and I might ask the chat, but it's we are moving pretty slowly on time, so I'm just going to move on with it. But notice that there's hard edges, like these dark edges here, on these parts, but where the parts intersect with each other, there's no dark edge there. So it's just kind of like gray. So that's another way that you know that these are two separate solid bodies inside inside your workspace here. Okay, so what we want to do, of course, is we want to subtract from the top body. We want to subtract the top body from the bottom body. In SolidWorks, there's probably 3 or 4 different ways to do this. Just for convenience sake, and just because I like this tool, I'm going to highlight the intersect tool. So the intersect tool allows you to just select however different bodies you have there, and it's going to create regions that they intersect, that they overlap, and that they don't overlap. And all I have to do is just in my graphics area, just select the items or the kind of areas or regions that I don't want in my final part. So here you can see this is just a very quick way to do sort of that subtraction method. And so now I have just the sort of cored out body there. So pretty cool. Okay, we do want to create some more geometry here. So for example, the front part of my screen is, kind of
yeah, you don't really want to be blocking your screen there, right? Also, right now, because you subtracted that, you would have it'd be pretty hard to get that in there past that lower lip.
That's true, yeah, and the lower lip would kind of interfere here as well. Yeah. So what we want to do is just want to kind of cut that out. Well, let's do it this way. If I select this face, which is the exact geometry I want to cut, and choose to do a sketch here, notice that face is still selected. So I can go right to converting entities in my sketch, which pulls in the outside edges of that face into my sketch, and then go right to an extruded cut. Right click through all, right click to confirm, and there it goes. It's gone like magic. So really quick mechanics there to quickly get rid of that material that I don't want to see anymore. Okay, some other things we want to do, maybe we want to round off some of these corners. So we'll do maybe a quick fillet here. Let's say, I don't know, is 10 too much? Who knows? Maybe not, maybe so.
Looks pretty good to me, Mark. I don't know. I think it looks all right.
Jeremy, I'm having a hard time grabbing this edge here. And this can be a big frustration because SolidWorks doesn't know what I want to fillet. It's thinking, okay, it could be any one of all these edges. But unfortunately, I want to fillet smallest and thinnest edge that exists in the part. So how do I grab that? It's trying to give me all these faces and stuff. Well, one way to do it that I like to use is like these selection filters. So I have a keyboard shortcut. It's default for everybody. It's the E key. E is in Edward. And if I click on that, notice that next to my cursor, I have what looks like a purple tornado. It is actually a filter. And so all that's going to do is allow me to only select edges. And it makes selecting that edge just super easy. So I have that. Boom. There we go. So now I've filleted those things off. And this is actually starting to look like a real part. However, no matter how much I shake my mouse, that thing doesn't go away. So it's still attached to there. So how do you get rid of it? And sometimes what a lot of people will see is they'll accidentally hit a key on their keyboard.
Yeah.
And they'll have this filter there and they don't know what they're supposed to do with it. So there's a couple of things that I would recommend, and they're either going to be the F5 or the F6 key. So if you hit F5 on your keyboard, you're going to get this filter. Usually it shows up down here. Let me fix that.
Yeah, mine's always on the bottom of the screen.
Yeah, there we go. So it's at the bottom of the screen, and you have this UI that you can use to get rid of them. F5 will get rid of that again. Or you can also hit F6, and F6 will just clear out any selection filters you have. So if you're writing anything down at home today, I would say that's a really good one.
F6 is like the key that gets you out of trouble a lot. I can't tell you how many times I've done that. I hit V or E or something like that, and
yeah, exactly. So, okay, we're almost done with this design. We have one last thing to do, and this is where I introduce the thread tool. I think this is just a really great tool. However, before we do that, I want to create a hole using the hole wizard. So let's go to features. I'm going to do hole wizard, and I'm just going to get this prepped up. So hole wizard, for anybody that doesn't know, is just a library of hole types that you can access, countersunk, counterbore, all that. It's all built into the SolidWorks interface. So what I want is this straight tap thread, and I can choose from a lot of different standards here. ANSI inch makes sense for me in my case because I have a 1/4-20 thread that I'm planning to thread into this thing. It's going to be a tapped hole. You do have some options here as well. Tapped hole. Sizes, they range from very, very small to very, very large. I have 1/4-20 is what I'm looking for. And again, we can choose things like the end condition, as well as even things like near or far side countersinks. So in my case, a near side countersink would be helpful, as you try to get the thread started, right? So let's go ahead and do that. I have all of my settings set. Let's go to positions. And all I need to do for this is just select the face that I'd like to position the thread on. And notice it does give me this preview. I'm just going to drop this in here, and it's going to place a point in this sketch that is creating on the fly. And you can put as many of these as you want. I only need one, and it needs to be in the center. So nothing's going to stop me from using my S key to access some of my sketch tools. And I'm just going to create a quick center line by hovering over that edge and grabbing those midpoints. So I know that it's going to be right in the center of my part. Then I'll grab my point, which I can drag anywhere, and just hover it over that line. Is going to reveal that midpoint of that line, drop it right on there. So now
got a couple comments about the filters, Mark. I think people like that. Eric likes the term purple tornado, and Mert Kapkin says that filter icon drove me crazy last year. So F6, I'd put a Post-it note right on your monitor to remember.
Yeah.
That's how you get rid of that.
Yeah, and but don't use it like most people do as your password. Like that wouldn't. It's not a very secure password. Okay, so we have this here. Now we could 3D print this part, and that would be fine. However, notice that the threads are not going to engage very well here. There's going to be some material, so I'd have to thread it myself. And me personally, I don't have tap and die, at Casa del Mark. So I have to do something different here. And this is where the thread tool really, really helps out. So
yeah, I mean, think about it. So for most people, the hole wizard is like where they need to go, but you're dealing with a very unique manufacturing process where you need to actually be able to print those threads out, right?
Yes. Yeah. Now, the nice thing for me is that, this is a 3D printed part, and the plastic that I 3D print out of is somewhat malleable. So these threads don't have to be exactly perfect. And, the thread tool is a very good tool for this. It's underneath the hole wizard. But when you bring up the thread tool, it will give you sort of this warning about the thread types and sizes. And this is just kind of a sort of a general warning that not everybody's thread is going to be exactly the same. So you want to make sure that you double check and verify that your the thread profile is going to be correct for your particular use case. So I'm just going to say OK here, because whatever thread is going to be in here is going to be about right for me. But you can customize your threads and do some pretty wacky stuff with this. I've made an auger before with this tool, which is pretty cool. So cool. So the way that this works is it just needs a place to get started with your threads. So I'll start here. And then we just want to do, we can do blind, we can do a certain number of revolutions, or just up to a selection. So let me just rotate my part around, and I'm going to choose this top surface here for where I want the threads to end. This is going to be an inch tap, and it's going to be, again, 1/4-20. And I'm going to use the cut thread method. And as we see from the profile here, it's going to cut these purple threads into my part. You can choose right or left-handed, lots of different options here. Now, if I confirm this, it looks pretty good. You've got some real physical threads in here that we're going to be able to use in our 3D print. They come out the top perfectly. Unfortunately, in the bottom, they did not escape out the bottom. And so that's a problem, because I would never be able to get this thread started. So let's just right-click on our thread and edit that feature. And there is this option here, and this is going to be really useful for us, that allows us to choose where sort of the threads start. So if I just choose this front face or this edge, I can now get that thread cut to extrude beyond just that bottom circular edge that I chose before. And now we actually have something that is usable in our print. Okay, great. So this, I think, looks really good. I think we're right around ready to get started. Let me just go ahead and save my part, and we're going to call this, let's just call this monitor mount, and save it. Okay, and then we've saved our part out. Now, for those at home that are, have the eagle eye, you may have noticed that my user interface is slightly different than maybe the SolidWorks that you're used to using. I'm using a tool called 3D Experience SolidWorks. It's a role on the 3D Experience platform, and this allows me to save all of my files directly to the cloud. And there's some real power and usability in that. So, for example, if I'm collaborating with other people, let's say in my company or elsewhere, and maybe I don't have a 3D printer at home, but they have a 3D printer wherever they're at, if I give them access to the place where my files are stored, they have direct access to these files. If they have 3D Experience SolidWorks, they can open this stuff directly, and they can go through the process that I'm about to go through as well. So this is really huge as far as collaboration is concerned. And so what I want to also show is that, not only can I save through this mechanism here directly inside the interface, but I can also put other files in there. So, for example, let's say I want to get an idea of whether or not this part will fit inside the 3D printer. If I go to File and Print 3D, it's going to open up Print 3D in my pane over here, and then you can kind of choose your 3D printer. It's got this huge library of these 3D printers in here. The printer that Mike Puckett let me borrow. Thanks again, Mike, for letting me borrow your printer. I appreciate that. It's been a lot of fun. But it's a Ultimaker, an Ultimaker 3. So you select this out of the list, you add it to your favorites, and now it's here. And what that does, it just gives you the overall envelope of the 3D printer. I want to select the bottom plane of my model, and if I had a little more time, I would go into, what would be the best plane to use for the bottom of my model. But I'm going to kind of skip that whole explanation for now, because we're not talking about, it's not a 3D printer class today, but maybe in the future we do a 3D printer class. So you'll notice that these red areas here are showing that the part is kind of sticking outside of the build envelope, which is not good. This means that this part is not printable in this orientation. However, inside this tool, we do have orient to fit. And so, of course, as you can see, it makes total sense that you just angle it and it would, be able to fit inside the envelope. So, I do have some reason to believe that, the Ultimaker 3 will be able to print this. Now, in a lot of 3D printers, in their footprint, there are keep out areas. And so whether or not it can actually print or not, we'd have to wait and see. We need to get into our slicing software before we know that for sure. But it looks pretty good. It looks like it has a good chance. And so that gives me those warm, fuzzy feelings inside. We also have a scale here. And a lot of times what I like to do with some 3D prints is just scale them up just a little bit. So maybe like 0.01 or something. And this just kind of grows the model. So any kind of intolerances in your 3D printer are kind of taken out of the picture because you just scaled up the part just slightly. And that will make sure that like my monitor will fit right inside this thing. It's not going to like kind of seize up, because if it's the exact dimensions, it's going to be a pretty tight fit. So we just can scale that up just a little bit.
Hey, Mark, you've just been given the go-ahead. Mike Puckett said, "Borrow, please keep it. I'm trying to declutter my place." It sounds like you better get that thing running in tip-top shape now.
Oh man, awesome! Wait, you're trying to declutter your place by cluttering up my place? Hey man, that's not cool.
Yeah. Hey, also really quick, so Eric made a comment about how he loves the Hole Wizard and he insists his coworkers use it for all their holes. No cut extrudes if they can avoid it. And he's given a couple of Hole Wizard tips to their weekly Swuggin leaders meeting. So I agree. You know, I know we're going back to something you did a while ago. The Hole Wizard's really important because it really standardizes the size of your holes, especially if you're creating them for mechanical purposes. You know, things like counterbores, countersinks, tapped holes, dowel holes. Yeah. Things like that are really important. And, you know, what's great about the Hole Wizard is it's really easy. You just define the center points of them and you're done.
Yeah. I will also add that downstream design challenges like adding fasteners, for example, are very much alleviated by using Hole Wizard, because SolidWorks understands, because you use the Hole Wizard, exactly what types of hardware can fit there. And auto sizing also works in that as well. So that's a great point, Eric, and thanks for bringing that up. I highly recommend everybody use Hole Wizard. It couldn't be easier to use tool, and it definitely alleviates some downstream headaches. So
the other question we have, Mark, and this pertains to the 3D printing operation. Mert Kapkin asks, won't the thread be too loose if you scale your model?
It depends on a lot of factors. So some 3D printers are very, very accurate, and some are not so accurate. So, you know, and even some of the less accurate ones, depending on which one you get, can be more or less accurate, or depending on how well it's been maintained, it can be more or less accurate. So yes, in some ways it might be too loose. And then in some ways, if you don't scale it at all, it would be too tight and you won't be able to fit it. So I have another kind of tool here. This is actually a good example. So this is like a little, let's see if I can get this thing to do what I want it to, but this is like a little toy. So it just kind of like, it breaks on you, I guess. Anyway, so, but it uses these magnets. And so I have these magnets in here. And I printed this off this printer. It takes magnets that are like, I think 6 millimeters in diameter. I got 6 millimeter magnets and I could not fit them in there. And I was trying to scrape it out with like sandpaper and like a knife and all this kind of stuff. And I had to remove so much material to try to get, you know, these 6 millimeter magnets in here. Whereas if I just scaled this up just slightly, they would have just slid right in. I could have used my, you know, super glue or whatever and just got them in there. But instead I had to opt to use like smaller magnets because it was just such a pain to try to scrape out extra material. So yeah, this is a great question. It just depends on your conditions.
Yeah, I think you bring up a good point there. So the Utilimaker, this is a fairly budget-friendly FDM style 3D printer. This isn't a high-end SLA printer or something like that. Your tolerances are going to be a little bit different. And what you're trying to do is accommodate those tolerances, basically, right?
Yep. And you know, if it is too loose on the threads, well, you can always print another one. So, so you know, it's a trial and error thing, which is exactly what 3D printing and, you know, kind of rapid prototyping is all about. So, but yeah, great question. So, I'm going to point out a couple more things in this tool. So, if I go to my preview tab, we can, for example, show faces that require support. So, support material is sometimes necessary. You are building this in 3D, so that means if there's any kind of like edges that are overhanging, they're going to need something to kind of support them. Otherwise, when you print it, it's just printing over air and it's just going to fall down. So we can see here there are some areas like these green areas that may or may not require support. And this goes back to the previous conversation. It just depends on your printer. Some printers are very forgiving when they need or don't need support. So And with that, you can kind of change this angle. So if I change this angle to 45, you'll notice that my thread here lights up because these threads have some overhang. They may require some support underneath them. So, sometimes what I do is I just try it without support. Sometimes I try it with support. We can also show striation lines. So I can choose my print height. So this is how high each layer of the 3D printer is going to print. And this is kind of a useful tool because I can come in here and I can say, oh, okay, I see that, we have kind of these big striation lines here. So this curvature here is going to have some stair stepping to it. Now, am I comfortable with that? Is that okay? Is that maybe something I want to post-process, sand down? So these are all questions that you can answer just by using the built-in tool inside SolidWorks. You can also generate these slices if you want. And now this gets into a workflow that may be a little bit more involved than just kind of a personal 3D printer. However, if you save out your 3D printed file to 3MF format, which is a relatively new format in terms of 3D printing, because most people use STL or something like that. But this 3MF format is specifically built for 3D printing, and it will allow you to apply colors and appearances in your file, as well as specify printer setup, for example, like the layer height. And this will actually change information inside your slicer tool to accommodate those preferences. So it's part of a sort of a larger workflow that we won't talk about today. But what I do want to do is just show saving this out. So at the bottom, I can save this to a file, let's say STL. And, I do have my different options here. So with STL, if I go to my options, you'll see that I have just a few different options around, how fine or coarse the resolution of the STL is. And this is going to have a big effect on the file size, which we aren't concerned about too much these days, but we do want to keep file sizes somewhat low. As a comparison, just to drive the point home with 3MF, notice that with 3MF, I don't only have those resolution options, but I also can include materials and appearances and slices inside that file, and that can help things downstream if I want.
So Mark, there was a question in chat from I'm not going to try to pronounce it. The question was, is this an actual slicer? And I'll let you answer that question because I think what we're doing here is something a little bit different than that. But somebody asked, does SolidWorks have its own slicer?
Yeah, it does. And again, it just depends on your workflow. But some 3D printers will take these 3MF files directly and just start printing them. So this 3MF is a huge jump in the technology that we've been using for 3D printing that's been going for decades now. So this is huge. More and more 3D print companies like Stratasys and HP, all these big ones, they are part of the consortium that has generated this file format, and their printers do support this type of thing. So, but again, it just depends on your workflow and your tools and that sort of thing. So, very good question. Okay, so I did mention that I can take this STL file, for example, and I'm just going to take this and drag and drop it. Actually, before that, let me just refresh this. This is my 3D Experience dashboard here, and I just wanted to refresh it to show you that these are the files that I just saved up to the 3D Experience 3D Experience platform in my space. And I was mentioning before how if I'm collaborating with other people, they can have access to this information. So here's Dan Designer, for example. Dan, in this scenario, let's say he's the person that has the 3D printer, and I want to collaborate with him. If Dan has SolidWorks, he can open these files directly. If he doesn't, I can just, drag these over here, and now I have the STL file up here as well for Dan to use too. So that's great. So I would show kind of, Dan's perspective on things, but for right now, because we are short on time, I do want to kind of cut to the chase. So let's go back to SolidWorks, and something that Dan is going to come back to me with is, when he slices this product, this tool, or sorry, this part, it's going to take maybe 4 or 5 hours to print. So Dan would like for me to try to create a revision of this that doesn't take so much time. And that's no problem. I can pretty easily do that. Now, in traditional SolidWorks desktop, the first thing that you would probably think that you would want to do is go straight to the configuration manager and create, a new configuration out of this. And that could work, but configurations make more sense, when you think about, maybe I want a different wall thickness, or maybe I want to have a different thread type. That makes a little bit more sense for configurations. But because I'm using the 3D Experience platform and it has a lot of these product data management tools built into it, I can instead go down here to my lifecycle options, and I can create a new branch. So this is something that for most SolidWorks users, probably very unfamiliar with. But what this allows me to do is just to try a bunch of different designs, and then, as just sort of like, different pathways, different ideas for how I want something to end up in the future. And then once maybe our team collaborates together and we look at all the designs, then we can all say, you know what, actually design C is the one that we prefer. And you can kind of merge all those back into the design stream and then continue on. This is a really powerful tool. And I just want to quickly show off what this looks like. Excuse me. So I'm going to choose a new branch, and then let's just give this a name. I don't know, we'll call it 3D print. Oh, I'm getting notifications here. Sorry about that. We're working over here. This is we're live. Okay, so so
somebody just removed one of your dashboards, though, it looks like.
No, don't remove my dashboard. All right, so I'm just gonna call this 3D print, and I'm gonna say branch. Perfect. Okay, so that's that. Now I still have the old file open, so I do want to open the new file. So let's close this out, and we're gonna open up the new one. We'll make some quick changes, and then we're gonna log off, I think, here pretty quickly. So, all right, just load this up, and it's doing some loading there. So this is just going to the platform, and it's gonna try to find stuff for me. So let's look for 3D print. No results found. Sometimes it's in my recent content here. Okay. All right, there it is. What is it doing to me here? Okay, let me just double check something here real quick. Oh, okay. Okay, well, since we're here, so notice that I do have monitor mount 3D print. So, these branches are all available. They're different, what we call physical products in the 3D Experience platform. They're all available. So again, anybody that has access to this collaborative space has access to all this stuff. So let's go back to SolidWorks. Let me just try this one more time. There we go. Sometimes we can be a little bit slow on me. There we go. There it is. Okay, I don't know what was happening before. All right, we're gonna open that up. There we go. Okay, so now we see that is our 3D print there. Oh, sorry, geez. Oh, that's what I was going to show. One thing I wanted to show here is that we can actually see the life cycle of these things. So this is a really cool visual way to kind of show this. So here's kind of this little branching off. That's the monitor mount originally, and then we're kind of branching off. So any of these design iterations that you want to try, you can see kind of this graphical representation of all these things sort of branching off. And then once they all come together, you can also see that graphically as well, which, I mean, it's just really, really cool. So, all right, let's go back. We'll make our changes here. Let's just do a sketch here, and we'll do a rectangular sketch. Boom, something like that. I'm kind of rushing through this last part because I do want to show the final result here. So I just want to center this. Let's make that vertical. And all right, we'll just do a quick extruded cut. Now you might think, uh-oh, Mark, you're just going to cut right through everything, but that's not what we're going to do. We're going to change this. We're going to use flip side to cut, and that's just going to cut everything outside of it. Boom. And there we go. We would add, some fillets and et cetera, but ultimately that is the part. We do have to move on, so I'm going to just quickly go back to my PowerPoint and show you what that looks like as it builds here.
Obviously a little fast forwarded, huh?
That is a little fast forwarded, yes. Oh, there it goes. Let's continue. Yeah, that's not the speed of my printer, but that would be amazing. That would be really great. So I think this took maybe an hour, hour and a half to print that. And there we go. That's my hand. I'm going to be a hand model one day.
Yeah.
And there's my 3D printed part. Okay, so very good. So that's the part there. Perfect. There we go.
So hold on, let's do a full shot. So you got the real part up there in your hand.
Yep.
Cool.
So all right, so that's my 1/4 thread. So we're just gonna thread that in there. Boom.
Oh, that's cool. Then your monitor. So I noticed in your actual final product, you have a couple little bosses that stick out of that. Are there a couple? Is that just to like add a little tension to the monitor?
Yeah. So on the back of the monitor stand is a Visa mount that I didn't have time to show, but that just keeps it from sliding back and forth like left and right. And that's pretty much it. So that's the final product. That's what it looks like. Just applied to the top of the camera. And here's a little video of some of us having just a quick conference call, and notice kind of like where my eyes are, they're sort of like up towards the camera. So, it's just sort of like being a little bit more engaging than, just staring down at your monitor while, you're having a conference call. And I think especially now, when we have a lot less physical connection with people, it's just so much better to, be able to kind of look at people when you're talking to them over teleconferencing. So anyway, so that's that. I mean, we do have to go, but maybe we have some time for just maybe one or two quick questions, maybe.
Yeah, that was awesome, Mark. There were great comments before Eric had to leave. He said the sketch picture tips alone were worth the time here. I think a lot of people were interested in, how the thread tool works with 3D printing. I think that's a perfect example of when you would use that thread tool in there. We've had a couple comments about future topics. More 3D printing cam is one of them.
Oh, cool. Yeah.
So, really, our producer put it in chat. We actually did a SolidWorks Live last week with Mike Buckley and John Milbury, where we went through a bunch of cam tools that are available to SolidWorks users from Delmia. And we actually machined a part out at the end of that show, which I thought was really cool. So for everybody tuning in, if you're not aware, SolidWorks Live Design is a bi-weekly or every other Thursday at 11 a.m. Eastern Time. We run this regularly. We have another show scheduled April 8th. We're going to have Brad Williamson on. He is going to be designing and drumming. I think he's designing a foot pedal for his drum set, and I am just checking. And we're going to have a different host on that show. So Jean Calise is going to be hosting that show. That's something to keep in mind. SolidWorks Live Design is going to have a lot of different hosts and presenters on it. So I'm going to be excited to be able to participate from the audience and just watch this next one.
Me too. That's going to be an awesome one. Definitely tune in for that for sure.
Yeah. And then John Moderano and Gian Calise are actually going to be presenting next week on the same time slot at 11 a.m. Eastern Time next Thursday on exploring 3D experience works. And I think they're going to have Jordan Tadachan to talk about modeling, doing some sub D modeling. So really cool episode to tune into there next Thursday as well.
Yeah, I'll be on that one too. I love all the sub D stuff, man. Like once we got X Shape, like I was just like, you can do anything. It's so cool. What a great tool.
Yeah. Well, Mark, I want to thank you for spending your morning with us and all of our viewers on YouTube. And they seem to really like it. We have a ton of comments coming in. Thanks to everybody involved. Thanks for the presentation. Learned so much to take away. So great job, Mark.
Awesome. Yeah, it was a ton of fun. Yeah, I can't wait to do it again. Thanks for involving me, Jeremy. This has been great.
All right. We'll see you all next time.
All right.